Alright, so this is what you need to do. So you have your setup, you have your 2 columns, your short diagonal support, and your long diagonal support. I've got 2 straight tracks taped to each other and a funnel. When putting this together, I really recommend putting the tape underneath. Like when I tape these 2 straight tracks together, I actually put tape under and on the sides. And again, I actually put tape under to connect the straight track to the funnel underneath and on the sides. This is to help get rid of friction, right? Because if you're putting tape on the track, you're creating a source of friction. Alright, so you will also notice that I have some stronger tape here. So any kind of duct tape or stronger tape you can use to tape your columns or your supports to the cardboard base. Anything else, so like column to column or straight track to straight track to funnel, whatever parts, please only use Scotch tape for that. But you can use duct tape or stronger tape to tape this to the bottom here. Alright, so what I'm going to do, what you see here is I've actually attached my straight track to the side of this column, but I'm not taping it very securely. You know, this isn't my roller coaster. I'm going to be moving this up and down to test it, so I just have one piece of tape here on the end that I can move up and down and tape and retape. So I'm going to start at a fairly high height. So remember, the question is what is the minimal amount of potential energy needed to make this marble go all the way around this loop. Please don't lose your marble. I only have 2 marbles. Can I show you a trick? Like, I know you all have hopefully Scotch tape or a holder like this. Inside that little holder is a great place to store your marble while you're working so it doesn't roll away. Alright, so I have my marble. So the first thing I'm going to do is I'm going to measure the height of this, and I want to measure to where I'm dropping the marble. So all the way at the top here, I want to measure right here. So I go ahead and I take my ruler, and that's 30. And this is a demo, so I'm not going to see. That's 30 right there. Here's my thumb. So that's at about 35. You can mark along this if it's paper. You can write on it, so feel free to write on it if you want to. So I'm going to start with 35. I'm going to put the marble all the way at the top here. Let it go. Right, and it went all the way around. If you want to, because this loop isn't attached to anything yet, you can hold it in place, and you're going to drop it, and there you go. It went all the way around. So in my data table, I would put 35 centimeters, and yes. Right, so then I would continue to move it down, move it down, move it down, test it at different heights, different heights, different heights. You know, so I'll test it at another height just for fun. So this height is 27. So I'm going to go ahead and drop my marble at 27 centimeters, and it went all the way around. So in my data table, I'd write 27 centimeters and yes. And then I would keep moving it down until I got a no. I'm going to move it to a very low height that I know won't work, right? So I'm going to drop my marble from this low height, and I'm definitely going to have to hold it here. And that did not go around at all. I think everybody saw the marble go back. So I would record that height, which is a height of 6 centimeters, and I would say no. Right? So again, the purpose here is to find the lowest height that the marble can go successfully around. So what is the least amount of potential energy that a marble needs to travel around this loop?